Creating a schematic symbol and PCB footprint for 15 different electronic components is a great way to start your journey as a PCB design engineer in electronic industry. Most of the entry-level job requires component library design skills as a by default requirement in the entire job description. So learning how to design a schematic symbol and PCB footprint is a key feature for your career in ESDM industry. These 15 tutorials are created considering entry level or beginners in mind, or also intermediate people who are having a 1 or 2 years of experience in PCB industry. The most important and amazing part of these 15 tutorials are they are divided into 4 important parts. First one is the datasheet study and understanding how to read a datasheet and how to identify the most important information required for component library design. Second part is understanding how to create a schematic symbol using EasyEDA by following user perspective as well as IEEE standard, not compromising on any electrical or mechanical details that are given in datasheet, how we can make it more user friendly so that designers can use it in their comfort. Third point is we understand how to design a footprint using Cartesian geometry, a coordinate system, and understanding how to make it easy for the assembly person to identify the first pin or maybe certain markers on the PCB footprint. So that is what the most important part of the entire tutorial series. Last but not the least, we also focused on how to combine a schematic symbol with a PCB footprint so that you can use it in your future projects as a component library. All these 4 steps in every tutorial makes it easy for anyone to learn at their comfort space. We also considered the intermediate or experienced people as our audience, and we have created 5 tutorials on SMD components. SMD components are a little complicated for the beginners to understand probably, but it is very important to have that skill when you enter into ESDM industry as a PCB design engineer. That's why our first 10 tutorials are comprises of through-hole components, schematic symbol, and PCB footprint. Whereas the next 5 tutorials from 11th tutorial to 15th tutorial comprises of SMD components, schematic symbol, and PCB footprint. In these 15 tutorials, we have considered most commonly used components for schematic symbol and PCB footprint design. First one is RGB LED. Through-hole RGB LED is widely used in indicators and most of the electronic items. That's why we created a schematic symbol and PCB footprint for them. Thereafter, we went to the NE555 timer. Stable multivibrator and bistable multivibrators are designed using this IC. That's why we created a schematic symbol and PCB footprint for that. Thereafter, we went to the 5-volt relay, a sugar cube relay which is widely used in small-scale switching application. PC817 is a optocoupler which consists of a diode and a transistor which is widely used for galvanic isolation in switching application. AC transformer schematic symbol and PCB footprint is a little customized one. Why? Because it is not available in a very standard manner with respect to the manufacturer. That's why we have given a detailed explanation about how to create a custom PCB footprint for the component which is available in market at a local level. 2W10 bridge rectifier, JST connectors, and LM358 schematic symbol and PCB footprints are the most amazing one in the entire through-hole category of components. The process of creating a sub-parts for this schematic symbol design, we started from L29 3D cord package IC. That is where we learned how to create a sub-part for the schematic symbol and use them according to the design engineering. Thereafter, the most important, perhaps the most amazing one is Atmega 328P-PU. Dual inline package, 28-pin schematic symbol and PCB footprint, one among the best in the through-hole category of schematic symbol and PCB footprint design engineering. From 11th tutorial, we started with the SMD components starting by MU-A741, which is an operational amplifier. A schematic symbol remains the same, but a PCB footprint with the SMD component. That's where we learned how to use the top layer copper pads for creating a PCB footprint with a Cartesian geometry. SMD RGB LED and 78M05, which is the SMD version of 7805, are the most commonly used SMD components in electronic component design engineering. We also covered how to design a schematic symbol and PCB footprint for LM2596, which consists of D2 Park PCB footprint with a various dimensions available. Last but not the least, we also covered SMD version of Atmega 328P-AU package, which is having a 32-pin schematic symbol and a TQFP PCB footprint. This is one of the most amazing and one of the thing which I have designed on the internet for the first time. All right, these are all the components that we have covered in last 15 tutorials. Trust me, it took more than 6 to 7 hours for each tutorial. Considering that it is approximately 100 hours of effort to create these 15 tutorials for you to learn absolutely free of cost. I believe this particular work or this particular effort will help you to grow in your career or start your journey as a PCB design engineer in ESDM industry. Nevertheless, if you get any doubt or any confusion or if you want any clarification on a specific part, feel free to comment down your questions in the comment section of that particular video so that I can reply according to the context. And also, if you have any suggestions to me, feel free to comment down the same comment section. I am very open to learn from you as well. After completing these 15 tutorials, if you are happy with our content, feel free to write your review or comment on a LinkedIn post by tagging our linked frequency page on LinkedIn. It will help us to grow in the community of engineers and technology space. Consider subscribing to our channel. It will be free of cost to you, but it means a lot to us to grow and reach to the more and more people who are interested to learn component library design using EasyEDA. That's all. This is all for these 15 tutorials of component library design. See you again in the next one. Until then, tune yourself to make a difference.